All right, friends, it's the next lesson that we're going to look at today, which is comparing numbers and distance from zero. Yesterday we talked about absolute value. Absolute value refers to the distance a number is from zero, and it's always written as a positive number. So today in the first activity, it's about opposites. So it says a is a rational number. Choose a value for a and plot it on the number line. A rational number means that any number that can be written as a fraction. It has the word ratio in it. We know that ratio can be written as a fraction. So I am going to pick a number for a, and I'm going to pick that a can be -3. So I'm going to label this a. And then it says, based on where you plotted a, plot -a on the same number line. So -a would be the opposite of that. So then I would plot it over here, which this makes this -a, so that would make that 3. What is the value that you plotted of -a? The value is 3. And then it asks us, Andrew said, if a is a rational number, -a will always be a negative number. Do you agree with Andrew? Explain your reasoning. And so based off what I started with, it said I could pick a rational number, that a represents a rational number. It does not say that a has to be positive. It just means that a has to be a rational number, and -3 is a rational number. And so the opposite of -3 is +3. And so in this instance, right, Andrew is not correct because it's not always going to be the opposite's not always going to be a negative number. If you take -3, the opposite of that would be +3. So we have to understand, we have to take that. A student today said, one of the great responses was they said, well, what about 0? In this situation, the opposite of 0 is 0, and so therefore it's also not negative. So it's good that kids are putting together these things. So in this situation, the answer would be, no, I don't agree. No, I disagree. Disagree because the opposite of a negative is a positive. And the reason for that is if a is negative, then -a will be positive. And that's how we understand that, because really what that means is it doesn't mean that one's positive, one's negative. We just have to say a rational number. We plot that on the number line. And negative numbers can be rational. So that's how we back our explanation up for that example. And hopefully that makes sense. Again, you can also look at 0. 0 is its own opposite. So it also proves Andrew is incorrect. The second thing we did is we looked at a submarine. And so we have this vertical number line that I drew in class. So I'm going to draw it here for you. And I put 0 here. And then 0 would be like where the waves are. And people made fun of my drawing because they told me that I wasn't a good artist, and they were basically being mean to me, but that's okay. So that's sea level, and we can write that out here in case you don't like my drawing. And then at -100 feet, we know there is a submarine. That's -100, so I'm going to draw my little submarine, have this little thing. And people made fun of my drawing of this as well. And then we're going to make comparisons to the submarine and other people's elevation. So it says, the first person says Laura's elevation is greater than the elevation of the submarine. So Laura is farther from sea level than the submarine. So I need a number that is greater but also farther from sea level. In this instance, I gave 150 feet, right? Because that is farther from sea level but also greater than -100. And so you can be technically up in the sky, right, flying in your plane, right, and that's technically above sea level, right, further away than -100 is, so that's Laura in the sky. Then it says Kate's elevation is less than the elevation of the submarine. So if Kate's elevation is less than the elevation of the submarine, we need a number that's less than -100. A number less than that is -101 or -101 feet. And then we're going to make a comparison statement. So negative 101 is less than negative 100. Then we could say the absolute value of negative 101, we're taking that, or 101 feet, which is the distance from sea level. So it's 100, I put 100 feet there, my bad, 101 feet from sea level. Emily says Emily's elevation is greater than the elevation of the submarine. Emily's closer to sea level than the submarine. So we need a number that's closer to 0, but also greater than negative 100. I'm going to choose negative 25. In this situation, negative 25 is greater than negative 100. My example, absolute value of negative 25 is 25 feet from sea level. And then Nico, it says Nico's elevation is the same distance away from sea level as a submarine. Well, same distance away on the opposite side would be 100. 100 is greater than negative 100. And then the absolute value of 100 is 100 feet from sea level. And then it says down here, Pierce says his elevation is less than the submarines and he is closer to sea level. Is this possible? So is it possible for a number to be less than negative 100 and be closer to sea level? So I'm actually looking for a number that's closer to 0, but also less than this value. And what we know about negatives is that negative, the further a negative is away, the less it really is in value. So no, it's not possible. Because a number less than negative 100 would be further from 0. And that's what we did in activity 2, which is helping kids understand, less than, greater than, equal to, with the addition of absolute value signs, and relating to this whole, where people are in relation to a number line. So it's pulling all these concepts in. In our last activity, students got to work together to come up with statements in equality mix and match. So they got to use these things up here to write true statements using the inequality, using symbols and to make inequality statements. And so I'm just going to go through a few here. So I'm going to start with ones that are difficult. So I have negative 7/10 is less than negative 3/5. I know that 3/5 is 60 hundredths or 6/10, which is greater because it's closer to 0 than negative 7/10. A way to write that in a sentence is 7/10 is less than, or I'm going to put negative 7/10 is less than negative, I know I'm being lazy, negative 3/5. I'm going to do another one. So I used, this symbol, I can cross that out. Now I'm going to use an absolute value. So absolute value of negative 8 is, let's say, equal to 8. So the absolute value of negative 8 is equal to 8, right? And then I'm gonna do, so I use this, and then I'm gonna use one more. So I'm gonna say, let's use, so negative 2.5, negative 2.5 is, let's see, greater than negative 4. So negative 2 5/10 I'm spelling things wrong. 5/10 is greater then negative 4. And I need to spell that out, 4. Negative 4. Yeah, I'm getting real lazy. So the goal of today was to, get used to absolute value using inequality statements and putting it kind of all together. So now I'm going to ask students to order things based off of least to greatest with absolute value. I'm also going to ask students to compare numbers using absolute value. And so they have to be acquainted with this concept. Couple things. I think that's basically it for today.